Hello, Maurieo! Maurieo reviews Engineering Math Quiz 7. Yeah, here we are for the number 7 maths quiz. So I think you all know the drill by now, as you've done 6 of them previously. So essentially I'm going to go through the model answers for this maths quiz. And provide a blank there in the Moodle site with it. So I would suggest, as I always do, that you go through the quiz, work out where you went wrong, and then see, convince yourself that you know how to do these questions. So if you ever get this question again or something very similar, you'll know how to do it. And then print out a blank and have a go. Prove it. Because if you can't do the question now, there's no way you're ever going to do it in an exam or test. That sort of makes sense, doesn't it? Alrighty, so let's go and see what we can do. So what I've got here is I'm going to first of all just get rid of my PowerPoint, and then I'm going to go to the big screen. So here on the left I've got the model answer, and over here on the right is your formula sheet, your ever-present mathematical companion. So let's have a look at the first question, and it says determine the equation of the following graph. So all you've done is given that graph. So how do we do that? Well, I believe the first thing I would do is I would go to my formula sheet here, and over here we've got the periodic function. So this is a periodic function, and I'd write down some information that we might know first of all. So amplitude A. So just looking at this here, well, first of all, we know that we've got the standard form of our graph. So we'll start at the beginning rather than halfway through. So we've got y equals a sine bx plus c. That's the one that we use for this graph to determine this equation. So we have to decide whether it's a sine graph or a cosine graph, remembering that we can actually use both, and I have given the two answers in there. So if we said, because we can see that this graph, that both the sine and the cosine graphs start, the starting point, like this would be, if this was a sine graph, the starting point would be there like that, and it goes up and round like that, and that's one cycle. If it was a cosine graph, it would start here at the top of the this peak here, and it would go down there, around there, and back up to there. So we do have to know the basic shapes of our sine and cosine graph. So sine graph there, cosine graph from there or there. So we could either say it's a sine graph shifted that way, or a cosine graph shifted a bit that way. So I'm going to go with the sine graph for my sort of thing. Now, the thing to look at here is, first up is amplitude A. Now, the amplitude A is this distance here, from here to the top of the peak. It's not double the distance, it's only the distance in each direction. So that's the amplitude from there to there, or from there to there, and there to there. That's the amplitude. Now, in this case here, we can see, or we can guess, that it's round about 3. So I've written down here amplitude 3. Now the period of the graph is, how often it repeats. So you can look at that anywhere. So you could look at the from there to there as one period, because that's of the sine graph. Or also, you can see from there to there as a period, not where it it starts there, comes round and back to there, and then starts again. And so what I've said there is for this graph here, the period goes from there, which is 0.75 to 2.75. So that's a period of 2. Okay, and there it's negative 0.25 to 1.75, and again a period of 2. So we can say over here it says period equals 2 pi over b. So we've got 2 equals 2 pi over b. Now we need to rearrange that a bit. So what I've suggested we do is multiply by b, get rid of that damn fraction. So multiply by b, so that gives us 2b equals 2 pi. Then divide by 2 to get b on its own, which is what we want for our equation. So with the amplitude 3, we've got 3 there because that's a, 3. And then we've got b equals, dividing through 2b over 2 is b, and 2 pi over 2 is pi. So b equals pi. All right, so we can put in b is pi, and now it all remains to do is to find c. Now, the other thing that we can look at is the frequency. Now, the frequency is actually, we can see here, the frequency is b over 2 pi, and you can see that it's just that flipped upside down, which means the frequency equals 1 over the period. So this is b over 2 pi. So the frequency is just it flipped up the other way. So whereas we had here that it was is b over 2 pi. So we can put b in there as pi over 2 pi, and so the frequency is 1 over pi, which I haven't written in there for some reason. But you can reassure there, but we don't need it because we've already know what b. Now the phase shift is c over b. C over b is the phase shift, and we can see here for this sine, if we say this is a sine graph, we've got a phase shift here of from there, it should be there to there, 0.25. So it's 0.25 to the left, and that's what we call a positive shift. If it's to the left, it's positive. The opposite to the way the numbers are going here, but that type of phase shift is positive 0.25. So we can put that in here because we know that the phase shift positive 0.25 equals c over pi. Now we multiply by pi, and that gives us c, so c equals 0.25 pi. And we can fill that in our equation, 0.25 pi. So there's the equation. There's one equation of that graph. That's one equation. That's one correct equation of that graph. Now, if we were to treat it as the cosine graph, but with a phase shift of 0.25 to the right, or negative 0.25, because if it goes to the right, you can see here, negative means shift to the right. So we've got a negative phase shift of a phase shift of negative 0.25. That's for our cos. So we could have 3 cos. Now A is going to be the same, whether it's sine or cosine. Won't make any difference. A is going to be 3. B is going to be the same as well. B is going to be a pi. Okay, but the phase shift will be different. So for the phase shift c over b, negative 0.25 equals c over pi. Multiply both sides by pi, as I showed here, and we get c equals negative minus 0.25 pi. So that's our equation there. So both of these equations define this graph, but one is a sine graph with a positive phase shift, or also known as the phase angle. It's got another name, phase shift or time shift, or it can be a cosine graph with a negative 0.25 pi. So both of those would be acceptable answers. In an exam or test, you only need to come up with one answer. Only one is necessary. So you just started with that basic one. Just to recap, start with the basic one. Write down your formula. Write down what you know. A for amplitude, work out B, phase angle C. If it does have a D, the plus D can shift it up or down. But we don't seem to deal with that at this level. And then fill in your formula, remembering that you can use sine, well, in this case, sine or cosine. Obviously, if it's a tan or something like that, that wouldn't be an option. But yeah, alrighty. So let's move on to question 2. Here's question 2, and it says, a mass oscillating on a spring obeys the following equation for displacement D. D equals 15 sine 3t plus 1, where D is measured in centimetres and t in seconds. Find 2 times in the same cycle when the displacement is 11 centimetres. Right, so it's a sine graph. It's a sine graph here like this, okay, with all sorts of, it actually goes from there, 15, well, it'll go from there. But what I've drawn here is just my basic sine graph here. This is my basic sine graph. And this one here, we have to look at it, and it says find 2 times in the same cycle when the displacement is 11 centimetres. So looking at a sine graph, the first thing we do is we use the formula and we say, well, 11 equals 15 sine 3t plus 1. All right. So, and then what we do is we got to manipulate the formula a little bit, because we're trying to work out times. So the answer, we're going to try and work out what t is. Well, it's the only unknown variable there, because they're giving us d, and that's going to be 11 centimetres. Okay, so we divide both sides by 15. We get 11 over 15 equals sine 3t plus 1. Now, there are many ways of dealing with this, but I think one way to deal with it is to let u equal 3t plus 1. So we get sine u equals 11 over 15. Now, I'll just usually get all set up here and find my calculator before I start, but I haven't done that today. So I need to go, I'm just over here on my second screen finding my calculator, and here it is. And I'm just going to bring that over here like that. Okay, so we get 11 over 15 down to there, and so we get sine u equals 11 over 15. So we let u equals 3t plus 1, u equals 11. So u equals sine to the negative 1, 11 over 15. And we need to make sure that we're in radians. Now, I've got to remember how to do that. I think it's shift setup, shift mode. Oops, things. So let's see if we can shift mode. Here it is, 4. So we're definitely in radians. All right, sine to the negative 1, 11 divided by 15. So that's shift sine 11 divided by 15, close the brackets, equals, and that will give us 0.823212. Okay, now that this is a sine, so that would be that value there, 0.823 round the 3 decimal places. So that would be that value there. So then we look at the sine curve, and we say, well, where else would it be that? And we know that obviously it's going to be there and there, okay, and that it's going to be that bit there is going to be the same. So that point there, if we're measuring from here, because this is pi here, and we minus 0.823, this point here is going to be pi minus 0.823. So that's their 2 spots where it's solution. So typically 2 solutions would be, that's what we want. But there are other solutions further down the track, but let's see how those ones work out. So let's starting with the first one, 0.823. So now we know that that's what u equals, and now we want to find out what t is. So 3t plus 1 equals 0.823212, because that's u, so we put 3t in there because that's what they equal. All right, so now we subtract 1 from both sides, gets 3t equals 0.823212 minus 1. Okay, minus 1, and that like so. And then we don't want 3t, we want 1t, so we divide through by 3, and that gives us this thing here, t equals, so now we've got to do this calculation. So 0.823, let's shift stow, I'll stow that in A. Okay. All right, 0.823 minus, so I'll just go answer, minus 1 equals minus 0.176, and then I've got to divide that by 3, equals, and so that gives us a time in seconds here. But hang on, that time is negative, so that means it's beforehand. It's actually happened before the spring has actually done anything. So that's not going to be any good. So that solution has to be discarded. And the question said we wanted to find 2. So what we have to do is find another one. So this is where we come out over here, and we know that these are periodic functions. And so we have to get another solution over here as it comes around here, which is 0.823, 2 pi. That should be 2 pi plus 0.823. There, I've got a little thing there. I'll just put a little line in there, I think, and just to make that certain, that should be a plus. Now we're going to have to just fix that up there. Control E. Oh, properties. So what happened there? Where's those properties? Oh, here, the properties are over here on the second screen. We'll just put those over here. So we won't want 10 points. We want it to be possibly just 2 points. 2 points, and we'll make it red just to match. Okay, so that's oops, we'll just move that a little bit into there. So that, let's just fix that up a little bit. Gone too far there. Here it is here. I'm going to delete that, and I'm going to put some text in there instead. Just in there, I'll just put a plus. Plus. That's the one. Can we move that into there? That's better. I think that, yeah, that's all good. And, oops, down there like that. So we've made that a plus now. So that's our second value. So we couldn't, the first one was no good. So now we're going to go to the next one. And that'll be 3t plus 1 equals pi minus 0.83212. And so we work that out. So I'm going to try recall A. Oh, there it is there. Yeah. And no, I'm not. I'm going to clear that or delete that. Oh, yeah. Minus answer equals. Okay. And then I'll add pi plus pi, which is effectively equals, and then divide by 3. Divide 3 equals. Oops, that didn't work. Okay, let's try again. Let's go recall shift pi minus recall A equals, oh, sorry, and minus another 1, minus 1 equals, that's where I went wrong. So it's 3t plus 1 equals pi minus that, minus 0.1 is 3t because that, divide through by 3, and then divide 3 equals 0.439460 439,531. Oops. Yeah, I think that might be a rounding error there. I'll just try that, just make sure that's again. So we go shift pi minus A minus 1 equals, divide 3 equals 0.43946. Oh, so I think that's because I've retained more decimals there rather than typing the number in. But that's near enough, good enough, 0.439 in both cases, so we'll accept that. All right, and then, so that's one of our solutions, and then our second solution here is going to be this value here of what we've got here, 2 pi plus 0.83212. So 3t minus 1 equals 2 pi plus 0.83. Subtract the 1. 3t equals 2 pi plus that minus 1. And so let's do that on the calculator. So shift pi times 2 equals minus A minus 1 equals, divide 3 equals, and oops, what have I done there? Oh, I think I've subtracted where I should have added. So let's go shift pi times 2 equals plus a minus 1 equals, that's better, divide 3 equals 2.035466. 2.035466. Okay, and that's what t there equals, 2.035. So just to recap on that, we know what d is when it's equal to 11. We put that in there. We substitute or let u equals 3t and do the sign. So sine to the negative 1, u equals 0.832212 and pi minus 0.832212 in the first instances. Now we check out the first one and find, well, that can't be because it's before the thing starts. So we need to find another one, a second one. So we know it's a periodic, and so it comes around to here. And this distance, 0.823, is 2 pi plus 0.823. And that's in there. So that gives us our third option. And then we can check out the second option, which is 3t plus 1 equals pi minus that. We rearrange that equation and we get t equals 0.439 around in that sort of order. And then we check out our second option like so. So yeah, that's pretty much it. We've gone through the test there and come up with the answers. It's a couple of little tricky little bits at the end, but in general fairly straightforward if you just follow set procedures. And don't forget to have your trig formula sheet with you, and remember to set your calculator to radians. So I think that's us done for that one. So cheers, see you.